Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 8 Kinematics in a Straight Line, Long Question Example 5. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A particle starts to move along a straight line from a fixed point O. Its velocity v meter per second t seconds after leaving O is given by v is equals to pt square minus qt, where p and q are constants. The particle reverses its direction when t is equals to 4 and its acceleration at that moment is 24 meter per second square. So for the question part A, find the value of p and of q. For the question part B, sketch the velocity time graph of the particle for the range 0 less than equals to t less than equals to 5. So within this question B, the part 1, hence or otherwise calculate the total distance travelled by the particle in the first 5 seconds. For the question B, part 2, state the range of values of t such that the velocity of the particle decreases with respect to time. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. So for the question part A, as you can see here, the question asks us to find the value of P and of Q. So it's involving two variables. When you see two variables, remember these guys, information lead you to equation and that equation will lead you to the solution. So since you have two variables, so you need to come up with two equations and that two equation will lead you to two solutions. One is P and another is Q in this case. Okay, so from here let us begin our discussion. So given that the velocity equation is equals to pt square minus qt. Okay, so the first information given by the question is the particle reverses its direction when t is equals to 4. So this is your first info. So let me label this. Okay, let us write it down in our discussion here. When t is equals to 4, particle reverses its direction. Okay, so from here, when a particle reverses its direction, this condition concludes that your velocity will be equals to 0. Okay, so from here, using these two information, we're going to substitute this into this equation. Okay, so from here, p times with 4 square minus q times with 4. So from here, you should get equals to 0. Okay, so from here you will get 16p minus 4q equals to 0. So this will be your first equation. So let me label this as equation number 1. Okay, so we're done with the information number 1. Let us move on to the information number 2. The information 2 mentioned that when time is equals to 4, its acceleration at that moment is 24 meter per second square. So this is your second information. Okay, so from here, when t is equals to 4, so from here the acceleration of the particle will be equals to 24 meter per second square. But then you only have the velocity equation here. So how to get the acceleration? No problem guys, we can differentiate the velocity with respect to time to get the acceleration. So from here, given that acceleration is equals to differentiation of velocity with respect to time. Okay, so let me box this. Okay, so from here you differentiate v with respect to time. So from here you get your acceleration a is equals to 2pt minus q. Okay, using this information given by the question, you can substitute into this acceleration equation. So from here, 2p you times with 4, okay, and then you minus with q. So from here you get is 24. So you calculate this, you should get 8p minus q is equals to 24. So this will be our second equation. So let me label this as the equation number 2. Okay, so now we have two equations and two variables. The rest is very easy, guys. You can proceed to solve the step by using the simultaneous equation. In this case, it is highly recommended that you use the elimination method. Okay, so from here, let us write down the two equations that we obtained from this working. So from here, 16p minus 4q is equals to 0. Okay, and then 8p minus q is equals to 24. Okay, so this is your equation number 1. And this is your equation number 2. Okay, so from here you can choose to eliminate either one of the variable, but in this case I choose to eliminate the variable p. So since you want to eliminate the variable p, so equation 2 you need to times the whole equation by 2. Okay, so from here you update this equation. So from here, this equation you can just copy paste since it has no change. Okay, however for the below one there will be some changes, where your new equation will be 16p minus 2q equals to 48. So these two equations you can minus them together since we wanted to eliminate the variable p first. Okay, so from here 16p minus 16p, it will become 0. Okay, so from here start with the left hand side. So negative 4q minus with negative 2q. So from here you left with negative 2q. Okay, for the right side 0 minus 48. So from here you get is negative 48. So from here negative 2q is equals to negative 48. So from here you should get your q is equals to 24. So this is your first solution. So let me underline the solution number 1 for the question part A. Okay, so from here once we get the value of q, now you can use this value of q and substitute into either one of these equation over here. So in this case I choose to substitute into the equation number 2. So let us continue our working. When q is equals to 24, so from here 8p minus 24 is equals to 24. So this negative 24 from the left hand side, you move it over to the right hand side. So it will become 24 plus 24, where you get 8p is equals to 48. So 8p is equals to 48. So to get the p, what you do, 48 you divide with 8. So from here you get your p is equals to 6. Okay, so this is your second solution for the question part A. So let me underline the solution. Okay, from here let us proceed our discussion for the question part B now. For the question part B, we are required to sketch the velocity time graph of the particle for 0 less than equals to t less than equals to 5. Okay, so let us begin our discussion. Since we know that the value of p and q, now we can use that and substitute into the velocity equation, where in this case you get the velocity equation is equals to 6t square minus 24t. For the next step, what we're going to do is we're going to construct a table consists of time and velocity. Since in the question they gave us the range that the time should be in between 0 up to 5 seconds. So we are going to construct the table accordingly. So please give me a moment to construct the table of time and velocity. Okay, so we have already constructed the table consists of time and velocity. So from here, let us write down the values of time that we wanted to find. So from here, let us begin with 0, 1, 2, okay, followed by 3, 4, and 5. Okay, so from here, what we're going to do is we're going to substitute this time value into this velocity equation, and we're going to calculate the value of velocity, and we're going to write it down over here. Okay, so from here, when you substitute these values, from here you should get your value of velocity is 0, negative 18, negative 24, negative 18, 0, and 30. Okay, so I hope you guys understand the explanation till now. So from here, once we get all the information of the time and velocity, now we can proceed to sketch the graph of velocity time graph. So please wait for a moment. So this is the complete sketch of velocity time graph. By the way, so sorry guys if the graph is not smooth enough. Okay, so we have done with the question part B. So let us move on to the question B part 1. Okay, where we need to calculate the total distance traveled for the first 5 seconds. Okay, usually what we do is we come up with a motion diagram of a particle, and from there we calculate the distance traveled. But for this question, it will be different. So what you're going to do is, in order to calculate the total distance traveled, we are going to use the area under the graph, where in this case we're going to use the integration method. Okay, since we literally plot the graph for the time interval 0 up to 5 seconds. Okay, so we're going to calculate the area under the graph, which is by using the integration method. Okay, so I hope you understand what I mean. So from here, to calculate the total distance traveled will be equals to modulus, okay, from the limit 4 and the lower limit 0, okay, integration of velocity with respect to time, okay, close modulus, plus with integration of 5, 4 with velocity with respect to time. Okay, not to forget to add the modulus as well, since we are calculating the distance, right? Okay, so from here, let us proceed our calculation. So from here, modulus integral 40, okay, your velocity in this case is 6t square minus 24t close bracket respect to dt close modulus, okay, and then plus with modulus integral 5, 4 in the bracket 6t square minus 24t close bracket with respect to dt close modulus. So from here, you get modulus square bracket 2t cubed minus 12t square close square bracket with the limit of 40 close modulus plus with modulus square bracket 2t cubed minus 12t square close square bracket and with the limit of 5 for close modulus. Okay, so from here what you do, you substitute into the limits and then you minus them respectively for this, and the same thing go for this. You substitute the upper limit value and then you minus with the lower limit value. Okay, so let me show you in the next step. So from that substitution you should get modulus square bracket negative 64 minus 0, okay, close square bracket and then you close modulus, okay, plus with modulus square bracket negative 50, okay, minus with negative 64 close bracket close square bracket and close modulus. Okay, let me move it a bit. Okay, so from here you solve this, you should get 64, and as for this side you'll get is 14. So from here 64 plus with 14, you should get your final answer is equals to 78 meter. So let me underline the solution for the question B part 1. Okay, let us proceed our discussion for the question B part 2, where we need to state the range of values of t such that the velocity of the particle decreases with respect to time. Okay, so from here when you take a look at this sketch, your velocity actually decreases from 0 up until 2. By the way, from this 2 is actually experiencing a turning point, and from this point onwards your velocity is increases. So from here your final answer will be 0 less than equals to t and less than 2. So you can ask me, so why you're not including the 2 over here? The answer is very simple. At time is equals to 2 seconds, the particle is experiencing a turning point, which in this case your particle is moving in a reverse direction, start to change its direction. So in that case your particle, I mean the velocity of the particle is not decreasing at time is equals to 2 seconds. So that is the reason why we don't include the time is equals to 2 seconds, guys. So I hope my explanation clears here. So from here, so for the question B part 2, your final answer will be 0 less than equals to t less than 2. Okay, so let me underline the solution for the question B part 2. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.